focus for the class will be towards containers, especially we'll be looking at Dockers. So in the DevOps lifecycle, I'll just go to the slideshow. So you could see that it is coming in the build stage, correct? Can anyone tell me what is the absolute necessity for Docker here when we say build and then Docker? One purpose it is trying to solve by using Docker instead of VM.
It has inbuilt functions, sir.
Can you just repeat?
It has inbuilt functions to run our application consistently, sir.
It is not inbuilt functions, but it has built-in packages, built-in binaries, built-in libraries, which is packaged and delivered, and it will be when you deploy it, every time it comes up with the same set of packages and binaries, similar to VM only. But the only thing that it is solving is, say, for example, if you're deploying VM, that is nothing but EC2 instance, right?
Yes, sir.
When you deploy an EC2 instance, over a period of time, you are installing some packages, you are making some configuration changes, right? Some
Yes, sir.
configuration changes you are doing it. So as long as you are keep doing something, right, the
Yes.
VM that you create next is not in sync with whatever you created earlier. This may have some set of XYZ packages, whereas this may have ABC packages. It all depends on whether you are doing it automated way or a manual way. But anyways, most of the times what you will see is some inconsistency between these two. In order to avoid the inconsistency between two, people started even thinking advanced, and they came up with a Docker. I mean, they came up with a container concept where you will be building only necessary packages, necessary libraries into a small application that is called container. So it's called containerization. See, you call it as virtualization, right? For creating a virtual machine, you call it as virtualization. Similarly, the Docker container creation is called containerization. Hope you guys are clear about what is containerization at this point at a high level. Okay, I would like to throw a couple of questions to you. One of you please unmute and then answer. When I say creating an environment or provisioning an environment, what does it mean? Provision a resource or provision a new environment. Soumya?
So creating an environment means we have a newly creating that example. We are creating Git using Git init command. So we're just creating the environment into our local or something we wherever we want to. Provisioning is somewhat like maintaining something, sir, or just looking for it. It's like logging or monitoring.
Okay. To some extent it is okay. Anyone else want to give it a try? Tara? Okay. I'll just go ahead and explain. Provisioning a resource or provisioning the environment or creating the environment is all about creating the necessary software resources like storage resources, computer resources, networking resources, databases, and installing other packages, everything. It's all about getting the basic infrastructure available for you, for the DevOps team to deploy the application, for the development team to deploy the application. Basically, when we say provisioning a new environment, it means creating the necessary required infrastructure for the application to be deployed and running. Any questions? For example, creating an application and deploying an application is like making biryani, right? So if you want to make biryani, is it possible that you just put it on a vessel and then start cooking? Is that possible?
No, sir.
So what do you need? Basically, you need a kitchen. You need a slab. You need a set of tools like your gas stove, gas cylinder, and some vessels, some amount of at least some groceries, chicken or vegetables, based on whether you are a vegetarian or non-vegetarian. Here, the basic infrastructure, it is, maybe you can think it as AWS cloud, which is nothing but your kitchen room, whereas EC2 can be considered as your platform in which you are going to put your stoves and everything. So that is probably your compute resource. Rest of the resources you can think of like your storage, database, or the other things that you call it as, right? I mean, you have a gas stove. The gas stove is connected to the um, a gas cylinder. That is called creating a networking. Storage is all about storing some groceries and then pulling the storage and then using that while you are cooking. So you should connect it with your day-to-day activities in order to understand provisioning the resource or creating the resource or creating the infrastructure. Is that clear now? Shweta,
Yes, sir.
am I audible? Can
Yes,
somebody?
sir.
Yes, Yes,
Okay.
sir.
Any doubts you have, you can ask me right away, because we have to be very clear on what is infrastructure creation, what is provisioning the infrastructure, things like that. So cooking on top of it, that's like an application deployment, whereas creating and managing the infrastructure is equivalent to setting up your kitchen. So what are we using to create infrastructure in our DevOps class, in our DevOps session? Terraform. Terraform is the tool that we are using to define or declare our infrastructure requirement. Where are we creating the resources? AWS Cloud. Say we are using Terraform to create the infra, that we put it in a simple text format, declarative language, and then we create these resources by running Terraform init, Terraform plan, Terraform apply in AWS Cloud. In order to run it manually, we can go to the git bash and run it manually. In order to run it in an automated way, what should we use? We have to use GitLab CI in order to automate the pipeline to create the resources in AWS Cloud. You create your Terraform code and put it in GitLab, and you configure CI, and that CI will take care of creating the resources in AWS Cloud. Is that clear to all?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So when we say dev, um, test, stage, and prod, right? Test, stage, and prod. What exactly it means?
As far as for environment and
Environments, correct.
infrastructure.
Yeah, infrastructure that is created for a specific purpose. Dev is specifically for developers who wants to validate their code in the dev environment. Testing is basically the environment used by testing team to validate the features, validate the functionality of the application. Staging is equivalent to production, but again, the same thing is used by QA team to verify all the features and validation, to verify everything. Whereas production is non, it is not touched by any of the local people, any of the organization. Within the organization, no people will touch it. Only for the deployment will go to the production server and then do the deployment. But whereas the operations done by whom? The customers.
Yes, yes.
Okay, the customers or the public or anyone in the world. Okay, so you just think about operations done by customers in the production environment, deployment done by DevOps team. Whereas dev, test, stage, pre-prod, whatever it is, that is done by DevOps team. The whole operations as well as deployment and operations done by DevOps team. DevOps team, when I say, it could be infrastructure team, it could be application deployment team, it could be SRE team, or it could be completely operations team. So there are 4 to 5 different teams involved in the during the before the release phase into production. So we have to, each and every small feature that is part of the application will be tested in dev. Then it will be it will be going to test, and then it will be promoted to staging. Once everything is working fine in the customer similar environment, it will be pushed or promoted to production environment. Any questions, any doubts on this?
No, sir,
Okay.
it's correct.
So is there any question? Is everybody clear on this?
Yes, sir.
Okay. So these are the different tools that we have seen so far. We probably require some of the things that we have already seen. Virtualization, you are already aware. We are going towards containers now. Okay. Even if you look at the list of items that we have seen so far, we have seen up to GitLab, but CI is still pending. Terraform we have covered, and we are going with the Docker. And after covering Docker, we'll be again going to GitLab CI. Because in the GitLab CI, we have some usage of Docker. So I'm shifting my focus to Docker, and then I'll explain about Docker, and then move on back to GitLab. Is that clear to everyone?
Yes, sir.
Okay. Okay. Some of the things that I wanted to highlight here, what is the goal of DevOps team? So you already aware that automation using CI/CD tools is one of the goal. That is as per DevOps toolchain. And then faster and repeatable delivery to customer, reduce downtime. So I'll again come back and give more focus on the reduced downtime. I would like to go back to this one, automation using CI/CD tools. When I say change log or history, right? What does it mean? Any idea? By using Git tool, we can actually go back and see who has done what and when the change was made. So it'll have a commit ID. It'll have a commit ID and it'll have a commit message. So using that, we can find out who is the author, who made that particular change, and when it was made, how it was made, what was the reason it was made. Everything will be trackable, traceable. So it allows you to trace or identify who has done what. And you can also repeat as and when it is required. For example, if you created one environment using the code that you have, that is probably dev environment. Say if you want to create a test environment, you can just rerun the same thing to create test environment. That is probably some configuration values that you need to change, and then automatically test environment test environment will be created for you. Uh, to save and to save time, be efficient, we are using Terraform tool. Instead of we create it manually, we ask Terraform to, we define everything in Terraform to create the resources in AWS cloud. For faster and repeatable delivery, we can follow any process anytime to create any of the required infra, and we can deploy the application, and then we can deliver the application to customer. Okay. When I say reduce downtime, Sami, you can unmute and tell me what do you mean by reduce downtime?
Latency in applications, sir.
No, Aishu.
Sir, unavailability of application.
Yeah. So you might have seen some application is put down during the weekend, especially on Sunday. You might have seen from Citibank or maybe Axis Bank that our system will be shut down. Even from SBI Bank and all, you might have received some messages that system will go down for some time, right? That kind of downtime, or maybe other server related issue, other infrastructure related issues will not come up because of usage of virtualization concept and containerization concept. So usually it happens, the downtime happens during upgrade and deployment process because you will have to put down some resources, you'll have to bring down some servers down and then install the packages on the server, and then you will have to start the server again. So that process is heavily reduced, or maybe it is not at all required by using DevOps. Especially uh, people were initially using virtualization concept only. Later on, we moved on to cloud. And using cloud, there are three different things that we can achieve. That is highly available, highly scalable, and fault tolerant architecture. Any idea what is highly available? Tara?
Yes, sir. Unavailability of application, like whenever you have any downtime, maybe any maintenance activity is going on, that time every incoming traffic they can route to your, I mean, live server or some backup server.
Okay. Basically, making use of the availability zone concept where you have data centers distributed in two different places, like minimum of at least two AZs will be there in any region, AZ1 and AZ2. In short form, we call it as AZ1, AZ2. Uh, Otherwise, it is called availability zone 1 and availability zone 2. That is nothing but US East 1A, US East 2A, like that. Sorry, US East 1A and 1B. So highly available is done through distributing the servers into two different availability zones. How do we achieve highly scalable application, highly scalable architecture? By using auto scaling feature. Auto scaling based on the some of the metrics like CPU, memory, or disk. All of these metrics, using some of these metrics, we can do auto scaling um, and achieve high availability, highly scalable architecture. Any doubts on this? What is HS? What is AS? HS means highly scalable. AS means auto scaling. So both are actually referring to the same thing. I just wanted to give a different short names for that. You can say highly scalable or auto scaling feature. Any idea what is load balancer? Anybody heard about load balancer so far?
Yes, sir. Load balancer will work as a reverse proxy, and also
Okay.
it automatically increase the resources as its use of the application.
So it basically distributes the traffic. What does it do? It distributes the traffic. Load balancer, the strategy behind or the concept behind load balancer is to distribute the traffic to different servers based on the requirement or based on the load. Okay. Also, it identifies if there is an instance which is not healthy, then it will not send traffic to this particular server, whereas it will route the traffic to the other server which is running. This is what is called fault tolerant. So fault tolerant means it identifies which one is fault, which one is healthy. So to the fault instance, it will avoid sending the traffic based on the health check. So how you do health check for you? You do a heartbeat check, right? Similar to that, it does a heartbeat check. It keeps on sending some request to check whether the response is whether it is receiving the response from the particular server. Then if the response is received, it will have a 200 okay. If the response is not received, it will have some failure like 404 not found, or maybe 503 connection timed out, 504 connection timed out, or 503 server error. So based on that, it will avoid sending the traffic to the particular faulty instance. That is what is called fault tolerant. So any doubts or clarity with respect to highly available, highly scalable, fault tolerant architecture?
Fine, sir.
Before cloud came into picture, doing all this was a very difficult task, but with the cloud in place, we are able to achieve this in a very easy manner. Hope it hope I'm making it clear, and then it is clear to everyone too. Soumya?
Yes, sir. Yes.
Okay. So the same thing if you want to achieve in on-premise. See, you might have heard about on-premise, right? On-premise means the data center which is running for your company, your organization within your private data center. In that, if you want to do it, you have to run multiple servers in order to achieve the same thing. But again, you have to do a lot of configuration. You have to do a lot of management. You have to have a lot of n number of system administrators to manage, or other administrators, software administrators, to ensure that system is highly available, highly scalable, and then fault tolerant. So they can also run Kubernetes in order to orchestrate your container world, container based applications. Okay. In terms of AWS cloud, what is a container orchestration tool? AWS cloud. ECS and EKS. ECS is kind of managed by AWS, and it is AWS cloud native container orchestration tool, whereas EKS is a Kubernetes based container orchestration tool, which is in AWS. So we'll have some introduction and some kind of application deployment after we complete our infrastructure automation for creating ECS cluster, EKS cluster. We'll do application deployment on ECS and EKS clusters. Any questions on this?
Sir, what is orchestration, sir, in DevOps?
Orchestration, the usual example I give you is uh, say you heard about music orchestration, right? The orchestra, which
Yes, sir.
happens
Yes.
in stage. So there is one person who manages everybody, right? Even though he is not doing anything, he manages everybody who needs to sing at what point, who needs to play that particular music at what point. See, he does orchestration. He does, who should do what. That's a kind of thing done by Kubernetes, which knows exactly which cluster, which instance is free, and where you can deploy uh, a new container. So Kubernetes is like an orchestration tool which deploys all the Docker containers or any other container platform into a cluster. Can anyone tell me why we need a cluster? to distribute the application and make it behave like it is running on a single system. So just make a note, go back and read about what is a cluster, what is a Kubernetes cluster, what is a ECS cluster, what is cluster in general. Just make a note and read about it, and give me a page of write up and share it to me. Okay, I'm moving on to the next one. Any more questions on this? Orchestration is basically, it means managing uh, managing the running containers. It can be auto scaling, it can be fault tolerance, it can be troubleshooting, it can be auto auto recovery of the running container. So there are so many things that orchestration can tool can do. But at a high level, it is all about auto scaling and making sure it is highly available. There are two things at a high level.
Okay, sir.
Okay. See, DevOps goal is also about creating a consistent environment. We already have covered this, but I'm trying to give more highlights or more focus on this one, because I mean we are using Terraform for creating the infra. What is IAC? Any idea? Anyone? When I say IAC,
Infrastructure as code, sir.
infrastructure as code. It is nothing but you are writing infrastructure in Terraform code and making sure that code is executed and then your resources created in AWS. Basically, that's what it means. Infrastructure as code means you are declaring your infrastructure as code so that that code can be executed and then resources can be created in AWS cloud. So in the consistent environment creation, it is not only about compute, it is also about storage like S3, EBS. So EBS is for elastic block storage, which is nothing but your system disk. Elastic file storage is to store some files which is highly available, highly scalable. Networking, you have already done it. VPC, subnet, route tables, and other network resources. Database, again, it's about creating resources like PostgreSDB, MySQLDB, or any other DB, whichever is required based on your application deployment, application development. So you will also be taking care of running and managing the servers. See, it is not about only creating the resources, right? You have to manage the existing resources that you created. So you need to constantly update the patches, you need to constantly update the security patches, and you should also monitor the servers. What would happen if we don't do any of the DevOps activities, whatever we have seen so far? You will end up having a lot of troubleshooting, why this is failing, what exactly the issue. There is, you will always see one server is running fine, whereas the other servers, so okay, it is not working. So that is because of the inconsistent environment or mismatching versions running on the different servers. So one of the usual statement people have it, it's working on my system, why it is not working on your server? That means it is not consistent. Say one server is like this, one server is like this, like this. So if you have the servers like this, I'm just giving a representation of size. So it could be the same size but different packages installed, different softwares installed, different libraries installed. So you will not have a consistent environment in order for you to test everything. Hope it is clear to everyone. Any questions on this? Tara, Soumya, Aishu.
No, sir.
Okay, because I mean, if you have any doubts or if you need any clarity, feel free to ask me, because this is again more fundamental, but it is very, very important. Okay, moving on to the containers introduction. How many of you are aware what is process, what is service? Please Let me know quickly. Soumya?
Process is we're doing and service we are getting, sir.
Sorry?
Process is we're doing and service what is we getting like that, sir.
Process and service both are same. See, uh, for example, if somebody wants to test whether you are alive or not, what do they normally check? Whether your heartbeat is fine, correct?
Yes, sir.
Whether your heartbeat is there. So something similar to that. There is something should be running on the system. It could be very basic SSH service, or it could be HTTP service, any service. Only when the particular service is running, you will say that that server is up. Correct? The
Yes, sir.
service is nothing but the process which is running for the to serve a particular service. So process is nothing but the actual daemon which is running for that particular service. So process, service, everything is almost same.
Okay, sir. Okay.
Okay, it basically serves a purpose, can be accessed via a particular port or IP address, a particular port and IP address. You know, right? I mean, every machine holds an IP address, and every service holds a port number. I mean, every service contains a port number. Every machine has an IP address. So whenever you want to access something which is running on the server, which is accessible via internet, what you do is you give a IP address and the port number. But we don't need to have IP address and port number. Why? Can anyone answer it quickly? When you say HTTP, when you say HTTP, it defaults to port number 80. When you say HTTPS, it defaults to, when you say HTTPS, it defaults to what port?
443.
4 4.
Yeah, 443. So you don't need to necessarily mention 443 because the default port is automatically taken. That's the reason why you don't see anything on the browser that it is showing 443 or 80. Normally, if it is a insecure protocol, it is port 80. If it is secure protocol, it is 443. What is uh, what is a Docker? So it is basically an isolated process which is running on a virtual machine or a physical machine, and which is again very prone to be killed or stopped. Other way to tell us, it is ephemeral in nature. So this word you have to make a note. Ephemeral in nature means at any point in time that can be killed, that can be stopped, that can run out of memory, that can run out of memory, that has no space at all. So some other issues will come up because it is an isolated process and it is a standalone. It is separated from your virtual machine, or it is separated from your operating system. Since it is very small in size, it is portable anywhere. How many have heard about Docker Hub, Docker Hub repository, Docker Hub registry? So we'll look at a Docker Hub where once a Docker is built, it will be pushed and saved in the Docker Hub. Docker Hub is a public repository where all the Docker containers are stored. It is lightweight. It contains only It contains or it is packaged only with the required binaries and libraries. Uh, because it is packaged with binaries and libraries, it is a lightweight. As long as it is built on Linux machine, that can run on any Linux machines, but it cannot be run on Windows machine. The container which is built on Linux machine has to be run on Linux machine, whereas the container built on Windows machine has to be run on Windows machine. So the other beauty or other advantage of running containers is you can run multiple versions of the same application. That we'll have kind of a demo in the upcoming classes. Okay. So moving on to the Linux processes. Linux process is nothing but a program which is in execution. It is a running instance or running state of a program. Processes are fundamental operating system execution, allowing for multitasking and resource management. So basically, processes are the uh, services which is uh, running to serve the incoming request. Say, for example, in your EC2 machine, if SSHD service is not running, so I'll show you an example next class. If SSHD service is not running, you will not be able to SSH to the machine. So SSHD is a process or daemon which is running, which serves uh, SSH connections. It is successful. SS will be successful. If it is not running, your SSH connection will fail. That I'll show a demo in the next class. So how do we stop and start the service using the systemctl commands? Or you can also use service command. The command to kill a particular process. It is just an example, but it is not very much required. So what is Docker? It pretty much explains the same thing. I'll share you the slides so you can just read about it. It is lightweight, standalone. The most important thing is you can create a consistent environment for the development. Every time you spin up a Docker, it exactly gives the same thing. I may not be able to create the same thing here, but this one and this one is exactly same. You also remember, right? I mean, when you create a new EC2 instance, that instance which is created on your account and which is created on others' account, say for example, Tara, Saumya, Sweta, Sindhu, everybody's EC2 instance is the same. Just the difference is it is running on their machine, their AWS account, and IP address is different. Otherwise, rest everything is same. If you run a command yum install some package, if it installs on your system, the same package will be installed on the other system also if you're in the same command. So that is what it means. It's a consistent environment. So similarly, Docker also provides consistent environment, which is one of the reason why it is very famous and popular. In fact, it is very lightweight. It is standalone, and it is very portable. It can be moved between different places because it is only in hundreds of MBs, maximum of 300, 400 MBs, not more than that. So it is portable anywhere. So some of the key characteristics: isolation, portability, efficiency, consistency, and size. As I said, it is very small. Boot time. Normally, how much time it takes for you to boot a virtual machine, EC2 machine? Tara, how much time it takes you to boot up a EC2 machine? Hello.
No, it is.
Maybe a couple of minutes, right?
But I see the VM can take a couple of minutes.
EC2 machine, maybe you can say that it's about a minute, right? So normally to run a container, to start a container, it takes only few seconds and not more than 5 or 6 seconds. It starts very immediately. Okay. Resource usage, it is very less resource it will be consumed. Moving on to the next one. So there are different concepts in Docker. Containers means the running container, running Docker container. Images means it is nothing but an ISO image. It is a software image or it is a Docker image. So it is nothing but which is a base for uh, base for you to before running the containers. So images are used to run the containers. To build images, you need Dockerfile. So Dockerfile is a starting point where you put all the information in a text file and then convert that to an image and then run the container using Docker run command. Docker Hub is where you store all the Docker images in a public registry. Docker volume is all about mounting the volume to your Docker so that it maintains a volume. It is persistent across when you stop and start the container. So usually when the container is stopped or killed, automatically it releases all the volumes which is there inside the Docker container if it is not mounted, if it is not persistent volume. Any questions? So here we are trying to compare two things, virtual machine and Docker containers. So you can probably go through this. I'll move on to the next one. Here, so we are talking about the port numbers that we have already discussed. What is TCP UDP? Every service is designed based on or built based on some of the protocol. It is TCP or UDP at the high level. At the low level, whether it is HTTP, LDAP, or SSH, based on some other protocol, the application is always designed. Default port number for SSH is 22. For HTTP it is 80. And the way to access using curl is with the port number in the end. If it is 80, you don't need to pass the port number. If it is 81 or 82, you have to use port number to access that particular service. This one is exactly the same as the previous slide. Docker images is nothing but the images which contain the actual operating system, container operating system. Containers are the one which are running containers. Dockerfile is all about the definition of what should be there in the Docker image. So we'll see closely what is there in the Docker file, and the Docker image will be pushed and pulled using Docker Hub registry. Docker Compose is all about defining multiple Docker files into a single Docker Compose file. Any questions, anyone so far? You feel it is tough to understand, Soumya?
No, sir.
Aishu, any feedback?
No, sir.
Okay. Tara, you're feeling comfortable?
Yeah.
Okay, so I would suggest you to go through this video since it is being recorded. Go through this video once again, and I'll also suggest you some videos from YouTube that you can go through it. So Docker file is a text file that contains some instructions to build a Docker image. This actually automates the process of creating the images that contains the application code. We'll talk more about how to create a Docker file, what are the different basic keywords that should be part of the Docker file, the from keyword, run keyword, what is a copy, what is the entry point, all of these things we'll talk about it in the next class. How does the Docker file look like is this one. So when we say from Ubuntu, it'll pull a Ubuntu Docker container, Docker image, and then deploy deploy Ubuntu for you, and then finally it will run a bash shell for you to you can log into the particular container later. Okay. Now, what is the difference between the physical machine, which is a usual way of traditional deployment, where you have a hardware. It could be bigger hardware also, like 2 terabytes of hard disk, 2 terabytes of RAM, um, some 20 to 30 virtual CPUs. So on top of that, if you run the application, even if it is very small, the whole system is going to be occupied. Instead of that, people came up with a virtual machine concept where you divide them into small VMs and then run your application on top of it. To overcome maybe again the inconsistency and efficiency, we again introduce container container deployment, where you just need to build only the required binaries and libraries in a package and use that package to run a particular service. That becomes an isolated process. So you can run the same application multiple times uh, with the same virtual machine, so that it is effective, and you can also do auto scaling. You can also maintain high availability. So you can clearly see how what exactly is behind your Docker containers. Docker engine is nothing but a process which is running, a service which is running to serve Docker containers, to manage your Docker containers. There'll be a infrastructure which is nothing but, you can say, EC2, or it's just a instance type. On top of that, you install your operating system, Amazon Linux or Ubuntu. On top of that, you will have to run Docker, install Docker. On top of that, you can run Docker containers by pulling a Docker image. You can run the Docker container using a Docker run command. So basically, how you have a Docker client, using that you can do Docker build, Docker pull, Docker push, and Docker run. Docker push, it pushes the images to a registry. Docker pull, it pulls the image from registry. Docker run, it runs on the local machine, on the virtual machine. It runs a Docker container on your local machine. So the workflow would be writing a Docker file, building an image, running a container, pushing to registry. Pushing to registry may come before also. After building the Docker image, we can push it, and we can also pull it from registry and then run the container. So that running the container is nothing but a deployment. So the command to build a Docker container, command to run a Docker container, um, we'll definitely see that in the next class. But how do we how do we pull a Docker container? How do we run a Docker container? This command is probably very important for you right now. You're you're just running the Docker container by directly pulling it from the Docker registry. But here it is from the local machine, which you built using Docker build command. The same thing you're pulling it here. Whereas other way to pull it is, you can see that Docker pull Ubuntu latest, that you can directly pull it from the Docker container, Docker registry, sorry. So this Nginx, you are pulling it directly from the Docker registry. So like that only, in the pipeline, we are trying to pull the Docker image of Terraform and start with the pipeline file, GitLab CI pipeline. So this command is to tag the local image and then push the image from local to the registry. So you also have similar to Git, you have a pull, you have a push, um, you have a Docker run, but that is not related to your this one Git. Whereas Docker push and pull is related to your Git commands. Git also we will use tag, but that we have not covered it. So it is exactly the same as last one. Uh, these things happen in the client, whereas Docker daemon is running on the server, on the host. Otherwise, you can say images are there in the Docker host, whereas container is running on the Docker host, whereas registry in the remote.
So registry is like repository, sir.
Yeah, registry is like repository, but it is only for storing the Docker images.
Okay, sir.
So that is called a Docker registry. It's not called Docker repositories. It is called Docker registry.
Okay, sir.
So uh, from Docker, so you can pull the image from Docker Hub and run a Docker container. So Some of the arrow marks here may be misleading, but just understand you can do a Docker pull from the container, from the Docker hub, and then run a container. When you want to push something to the Docker hub, you have to do a Docker push. So this probably you require some more time to understand. We'll talk about this later. Okay, that's all I had for today's presentation. Any questions, anyone? You want me to go back to any of the slide and then explain something? Feel free to ask questions. Okay, I hope everyone is clear on this. We'll connect on Monday. Thank you all. Bye bye.